Okay, we'll do another example here. This is a vertical rotation. This one is where the force diagrams are super important. So we have a 35 kilogram boy on a Ferris wheel, radius 10 meters, and it's rotating with a period of 1 revolution every 20 seconds. So the period is 20 seconds. Okay, what's the normal force of the boy when he's at the top? So it's a Ferris wheel, so the boy's sitting on a chair. So when he's at the top, you can picture like this, right? Like, well, first I'll do a little drawing, just like here's the seat. There's the center of the Ferris wheel, and the kid's like this. So the seat is pushing up on the boy, and yay, super fun. There's normal force pushing up and gravity coming down. So when he's at the top, Fn is upwards and Fg is down. And also we know when he's at the top there must be an Fc pointing down. The net force has to be pointing down. That means Fg has to be bigger than Fn. So Fc is equal to Fg minus Fn. So that's the physics part of this. That's super important. So let's figure out some things here. If we know the period and we know the radius, right away we can get the centripetal acceleration. So AC is equal to 4 pi squared r over t squared. So that's 4 pi squared 10 meters squared divided by, nope, sorry, not squared, divided by 20 seconds squared. So that is equal to 4 pi squared times 10 times 20 squared divided by, so 0.987. So since this is uniform circular motion, that will be the centripetal acceleration for all these questions. It won't change. Okay, if we know AC, then we can calculate FC. It's mass times acceleration. Mass is 35 kilograms, so 35 kilograms, 0.987 meters per second squared. So FC is 34.54 newtons. Again, that will be a constant value. Since the mass is not changing and the centripetal acceleration is not changing, therefore Fc is constant as well. So this applies, Fc is the same for A, B, and C as well. Alright, we're looking for the normal force. So let's take this equation here and solve for Fn. So Fn is equal to Fg minus Fc. So that is equal to mg, so 35 times 9.8 minus 34.54. So the answer to question A is 5, 9.8 times, and I subtract those two. So I get 308 newtons. Okay. B, what happens when he's at the bottom? So at the bottom, similar kind of thing. There's the bench. Here's the boy. Yay. So happy. Fn is still pushing. Fn is still pointing up, and Fg is still pointing down. But this time, slightly different. That's the center of the circle, so Fc has to be pointing in that direction. Therefore, we know that the upwards force has to be greater than the downwards force. So here's the force diagram. There's Fn, and Fg has to be smaller. So in this case, Fc is equal to Fn minus Fg. So let's calculate. So this time, Fn is equal to Fc plus Fg. So that is 34.54 plus the 35 times 9.8. So this time it's 378 newtons. And I think that if you've been on Ferris wheel or anything like that, I think that would kind of agree with your feelings. As you're spinning, when you get, especially if it's fast, as you get to the top you feel lighter, and then when you get to the bottom you feel heavy. You feel like you're being squished into your seat. And it's not just a feeling, that really actually is what's happening. When you're at the top, you feel 308 newtons. When you're at bottom, it's 378 newtons. Question C. What does it take to feel weightless at the top? So if you feel weightless at the top, it's kind of like A, only Fn is so small, weightless, it's the idea of you're losing contact, that it's actually zero. So as soon as your bum comes off that seat, you'll feel weightless. You feel like you're about to fall because nothing's pushing you up. So in this case, there is no Fn, so Fc is equal to Fg. So in order for that to happen, you need an Fc of 35 times 9.8. So that's 343 newtons. So what's the acceleration? So acceleration for that would be Fc divided by mass. So that's 343 divided by 35. So, oh, that's 9.8, yeah, of course. I didn't even need to calculate that stuff. So you need an acceleration of 9.8. So AC is equal to v squared over r. So v is the square root of a times r. So that's 9.8, oops, times 10, square root, you'd have to be going 9.9 meters per second squared, or meters per second.